So this new topic is about work, energy, and power. Let's discuss what do we need to know about work in mechanics. Okay. So work done is equals to force times distance. Or in short, we'll say work is equals to FD. Unit is going to be joules. For example, there's a force of, let's say, 500 newtons, for example, driving a lorry upwards, and the distance of the slope or the path is, let's say, 800 meters. Then the work done by this driving force of the lorry is going to be 500, which is the driving force, times 800, which is the distance covered by that force. This would be work done by the driving force, and you'll be told that this is the driving force. I'm calling that FD, driving force. Force of the engine is the driving force. And then you might be asked to find work done by the resisting force. So you might be given a resisting force in the question that this lorry is going upwards, and then there's a backward resistance in the opposite direction of, let's say, 50 newtons. And you might be asked to find the work done by the resisting force. Then the formula is the same. Work done is equals to force times distance. But this time you will use the force exerted by the resisting force. So it's 50 times 800. So the formula is the same, force times distance. If the question asks for the work done by the driving force, then you're going to use the driving force times distance. And if the question asks for the work done by the resisting force, then you use resisting force in place of F times distance. Okay. Next is energy. Let's discuss what we need to know about energy. So we have kinetic energy and potential energy. Kinetic energy is half mv square. Its unit is joules as well. Okay. Most of the times you'll have to find change in kinetic energy, not just kinetic energy. Change in kinetic energy, which I'm representing as delta KE. Okay, now this would be half mv square minus half mu square, provided v is bigger than u. If v is bigger than u, so then you find the bigger kinetic energy first, then the smaller kinetic energy, and then subtract them. For example, an object is going down the slope. Let's say its initial speed is, let's say, 0, and its final speed is 5 meters per second. and let's say its mass is 50 kgs, then the formula for change in kinetic energy would be half times mass. Sorry, mass should be in grams, not kgs. Into 50 into 5 square minus half times 50 times u square, which is 0.
And miss, if U is greater than W, then what?
वो मैं बताती हूँ. अच्छा, it's going to be 50 kgs, not grams. Because the SI unit for mass is kg. So kg इधर होगा. Grams में नहीं given होगा. अगर grams में given होगा, तो then you'll have to convert it. So sorry, that was a mistake. It's supposed to be in kgs. So it's the unit given to you will be in kgs. Okay, acha. So if u is bigger than v, then you simply write u term first, half mu square minus half mv square, because it's the bigger kinetic energy minus a smaller kinetic energy. Otherwise, you'll get a negative answer, which we will be avoiding. So if U is greater than V, then you write the kinetic energy using U first, and then subtraction sign, and then the kinetic energy using V first. Okay. For example, if you're told that a particle or an object goes up the slope with an initial speed of 5 and a final speed of, let's say, 1, and let's say mass is again 50 kgs. So then the change in kinetic energy would be use the bigger kinetic energy first using U minus smaller kinetic energy using V. 1 square. Okay. So this is kinetic energy. Let's talk about potential energy now. Simple formula for potential energy is mgh. Kinetic energy is the energy due to the speed, and potential energy is the energy due to the height of an object. Hence, there's an H in the question. Okay, now this height is always the perpendicular height. Height is the perpendicular height. Now, this formula is for finding potential energy at a particular height. You'll have the mass, you know G is 10 meters per second square, and you'll be given a height, and you'll be asked to find potential energy at this particular height. And if you have to find delta PE, change in potential energy, then it's the same formula mgh1 minus mgh2, provided h1 is bigger than h2. For example, there's a slope and a particle is here at a certain point, and then it's here at a certain point. And you have to find change in potential energy. So this height is bigger. You may call it h1, and this height is smaller. You may call it h2, but you'll be doing mgh1, the bigger one, bigger potential energy minus smaller potential energy. And we'll most probably be finding these heights using uh, right angle triangles. You'll be given a theta and you'll be able to find the perpendicular height because the perpendicular height is not given in the question. You will use trigonometry to find it. Okay, so most of the time they'll ask for the change in potential energy instead of a simple potential energy. Okay, so that was all about energy, and I think I've already discussed the unit. The unit for energy is joules as well. Okay, now we talk about power. So the formula for power is you actually have two formulas. Power is equals to work done over time taken, or power is equals to force times velocity. So power is equals to F times V. The unit for power is watts. So if the question talks about work, time, and power, then you'll be using this formula. And if the question talks about power along with force and velocity, then you'll be using this formula. Depends on the data given. Okay. And then lastly, a very important formula that you will probably be using this in almost every question of this topic. That is work. This is the equation work done by driving force plus loss in energy equals to work done by resisting force plus gain in energy.
Miss, can you please zoom out?
You want the previous part?
जी मिस बस पावर वाला देखना था.
This is a very important formula. Work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Before we start the topical questions, one more thing you need to know is that when an object is traveling at its maximum speed, let me draw the graph. For example, this is speed, this is time. So when the object is traveling at its maximum speed, at maximum speed, acceleration is equals to 0 because at this, in this region, the speed is not changing. So you can deal with it as a constant speed. You can say that the speed is constant in this interval. So acceleration in this interval will be equals to 0. And then forward force is equals to backward force. And forward force in this topic would be the driving force, and the backward force would be the resisting force. Driving force is equals to resisting force. Okay, now let's start the questions. Okay, question number 1.
मैम ये ड्राइविंग फोर्स और रेजिस्टिव फोर्स वाला एक बार एक्सप्लेन कर सकते हैं?
तो अब जो टॉपिक है ना, इसमें जब लेट्स से कोई भी लॉरी होगी, अब पार्टिकल नहीं होंगे, अब प्रॉपर कार्स वगैरह होंगी, तो उसको जो अपवर्ड फोर्स लेके जाती है उसके इंजन की ड्राइविंग फोर्स होगी। ठीक है, तो अब हम फॉरवर्ड फोर्स को क्या करेंगे, ड्राइविंग फोर्स, और उसको जो रेजिस्ट कर रही होगी ना, वो रेजिस्टिंग फोर्स होगी। सो इफ द क्वेश्चन सेज कि ये अपनी मैक्सिमम स्पीड पे चल रहा है, तो मैक्सिमम स्पीड पे आपने याद रखना है कि एक्सेलरेशन इज 0। तो फिर वो जो फॉर्मूला होता है फॉरवर्ड फोर्स माइनस बैकवर्ड फोर्स इज इक्वल्स टू एम ए। तो ए तो हो गया 0, तो फिर फॉरवर्ड फोर्स इज इक्वल्स टू बैकवर्ड फोर्स हो गया। तो ड्राइविंग फोर्स इज इक्वल्स टू रेजिस्टिंग फोर्स if the question says that the lorry or the car is moving at its maximum speed. Okay. Actually, let's take a look at the question. A lorry P of mass 1500 kg climbs a straight hill of length 800 meters. Okay, so it's going upwards. The length of the hill upwards it is 800 meters at a steady speed. What do we know about steady speed? That the acceleration is 0. That means forward force equals backward force. Okay. So a lorry of mass 1500 kgs, let me draw the lorry, and its mass is 15,000 kgs, is climbs a straight hill of length 800 meters. It's going upward since it says climb. The hill is inclined 2 degrees to the horizontal, so this angle would be 2 degrees. For P's journey from bottom of the hill to top, find the gain in gravitational potential energy. Okay. So we have to find how much is the gain in potential energy from the top to the bottom. Okay. Let's say this is the top and this is the bottom. Then what's going to be the change in potential energy or the gain in potential energy? We have to use mg height 1 minus mg height 2. Now height 1 should be the bigger height, so this would be height 1. And height 2 would be the smaller height at the bottom, which is this is h2 and this is 0. So change in potential energy would be mgh1 minus mg0. Okay. Now, what is m? It's given in the question, 15,000 kgs. G we know is 10. And height h1 is this perpendicular height. Height in potential energy is always the perpendicular. So we can find it using trigonometry. We already know from mechanics that if this is 800, वो हम काफी करते थे mechanics में, और यहाँ पे 2 है, अगर 2 डिग्री है, तो हमें पता होता था कि जो ऑपोजिट कंपोनेंट है वो साइन कंपोनेंट होता था. सो ये हो गया 200 साइन, सॉरी 800 साइन 2. और जो एडजेसेंट कंपोनेंट होता था वो कॉस कंपोनेंट होता था. सो 800 cos 2. So either directly देख लो कि the perpendicular height is going to be 800 sine 2. But if you're not comfortable doing it this way, then you have to use the longer approach. Let's call this x. And now we will have to use, so sine 20 is equals to opposite over hypotenuse. So x is equals to 200 sine, 800 sine 20. Sine 20 नहीं है, sine 2 है, sorry. Okay, so h is going to be 800 sine 2. This should give you the gain in potential energy, which is 4187,939.04. एनर्जी है तो यूनिट है जूल्स. और 3 सिग्निफिकेंट फिगर पे नॉन एग्जैक्ट आंसर को राउंड ऑफ करते हैं. सो 419 and then 1 2 3 4 4 zeros. This is the change in potential energy or the gain in, gain ही पूछा था ना, या gain in potential. Part B. The work done by the driving force, which has a magnitude of 7,000 newtons. Okay, so we know the formula for work done. Work done is force times distance covered. So work done by driving force would be force, the driving force, which is 7,000 newtons given, times distance covered by the lorry is 800 meters. So 7,000 into 800. 56, 5 zeros. And the unit is going to be, since this is work done, it's joules as well. इसको मार्किंग स्कीम में शायद वो 5600 किलो जूल्स भी लिखते हैं. Still means the same thing. Okay. Then it says part C, work done against the force resisting the motion. Okay. Now we have to find work done by the resisting force. Okay. Resisting force हमें question में given नहीं है. तो हम क्या करेंगे, हम दूसरा वाला फॉर्मूला यूज कर लेते हैं जो मैंने एंड पे लिखवाया था. और ऑलमोस्ट इन एवरी क्वेश्चन of this type you'll be using this formula. So for part C, I'm going to use the formula work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. And we have to find work done by resisting force, work done against the force resisting the motion. So yes, you have to find this. Work done by resisting force. ये find करना है. इसको x कह देते हैं. Equals to, अब what do we know? We already know work done by driving force. हमसे निकलवाया हुआ है work done by driving force. अच्छा, part B में हमने निकाला था. Work done by driving force, that is 56,000,000. 5,600,000. So we already know this. Plus loss in energy. अच्छा, लॉस इन एनर्जी और गेन इन एनर्जी. अब इनमें से एनर्जी हमने पढ़ी हुई है काइनेटिक एनर्जी और पोटेंशियल एनर्जी. वी ऑलरेडी नो फ्रॉम पार्ट ए कि पोटेंशियल एनर्जी तो गेन हो रही है. वैसे भी क्वेश्चन में देखो हाइट इंक्रीज हो रही है. पहले इनिशियल पॉइंट पे हाइट 0 है और फाइनल पॉइंट पे एट द हाईएस्ट पॉइंट ऑफ द पीक इट हैज इट्स मैक्सिमम हाइट. सो पोटेंशियल एनर्जी इंक्रीज हो रही है और क्वेश्चन में वैसे ही कहा हुआ था फाइंड गेन इन पोटेंशियल एनर्जी. सो ये जो वैल्यू आपने फाइंड की है पोटेंशियल एनर्जी के गेन की, दिस वन, ये हम गेन इन एनर्जी के साथ लिख देंगे इन द फॉर्मूला विच इज है गेन इन एनर्जी. इधर लिख देते हैं एक्स के साथ. प्लस gain in energy is going to be 4187939.04. Okay. Plus loss in energy. Now we need the energy lost in the system. So potential energy तो lose नहीं हुई. अब काइनेटिक एनर्जी को चेक करेंगे, क्या काइनेटिक एनर्जी लूज हुई है. काइनेटिक एनर्जी बॉटम पे क्या होगी और काइनेटिक एनर्जी टॉप पे क्या होगी. हमें स्पीड नहीं गिवन बॉटम और टॉप पे. ठीक है, हम ये कह देते हैं कि बॉटम पे हाफ जो के ई होगी वो होगी हाफ एम यू स्क्वायर और टॉप पे कह देते हैं ये होगी हाफ एम वी स्क्वायर. तो अब देखो क्वेश्चन में कहा है कि स्टेडी स्पीड है. इसका मतलब है स्पीड चेंज नहीं हो रही. इसका मतलब है काइनेटिक एनर्जी भी नहीं चेंज हो रही. बॉटम पे भी वही काइनेटिक एनर्जी है क्योंकि यू की सेम वैल्यू है और टॉप पे भी वही काइनेटिक एनर्जी है क्योंकि v की सेम वैल्यू एज u बिकॉज क्वेश्चन सेज द स्पीड इज स्टेडी. सो देन देयर इज नो चेंज इन काइनेटिक एनर्जी. अगर आप यहाँ लिख भी लेते हो ना फिर आप उसके साथ जीरो लिखोगे या आप इधर डायरेक्टली जीरो लिख सकते हो क्योंकि स्पीड स्टेडी है. काइनेटिक एनर्जी तो ना उसमें ना गेन आ रहा है ना लॉस आ रहा है क्योंकि बॉटम में भी वही काइनेटिक एनर्जी है और टॉप पे भी. और यू कैन राइट इट लाइक दिस, हाफ, इसको ब्रैकेट में कर लेते हैं, हाफ टाइम्स m टाइम्स v स्क्वायर माइनस हाफ टाइम्स m टाइम्स u स्क्वायर और उसके साथ उसको जीरो कर दो या डायरेक्टली जीरो लिख लेना चाहिए, वो ज्यादा बेहतर होगा बट यू नीड टू नो द थ्योरी बिहाइंड इट. काइनेटिक एनर्जी में कोई चेंज नहीं आएगा क्योंकि स्पीड इज कांस्टेंट. सो लॉस इन काइनेटिक एनर्जी का ना लॉस है ना गेन, सो इस साइड पे जीरो आ जाए. Okay, now you make x the subject, so 56,000,000 minus 4187939.04. इससे आंसर आता है 141,000,000 joules. After rounding, बल्कि before rounding, let me write that answer. 141,2,060.396, which gives 141 and then 4 zeros. Joules. This was part C of part 1. अच्छा part 2 देखते हैं इसका. अगर कोई क्वेश्चन है तो प्लीज साथ साथ पूछा करो अनम्यूट करके. Part 2 देखते हैं. Part 2 says that a second lorry Q also has a mass of 1500 kg and climbs the same hill as P. The motion of Q is subject to constant resisting force of 900 newtons and Q speed falls from 20 at the bottom of the hill to 10 at the top of the hill. तो अब हमें पता चल गया कि काइनेटिक एनर्जी का कोई लॉस है क्योंकि इनिशियली स्पीड ज्यादा है बॉटम पे और हाइट पे स्पीड कम हो गई है. सो ये इसको काइनेटिक एनर्जी के लॉस में यूज करेंगे. फाइंड द वर्क डन बाय द ड्राइविंग फोर्स एज क्यू क्लाइंब फ्रॉम द बॉटम ऑफ द हिल टू द टॉप. ओके, वर्क डन बाय ड्राइविंग फोर्स बोला है तो हम वही अपना फॉर्मूला यूज करते हैं. वर्क डन बाय ड्राइविंग फोर्स प्लस लॉस इन एनर्जी वाला. सो वर्क डन बाय ड्राइविंग फोर्स plus loss in energy is equals to work done by resisting force plus gain in energy. Okay. Find the work done by the driving force. तो यहाँ x आ गया plus loss in energy. ये हमें बताया हुआ kinetic energy कम हो रही है from bottom to top. So इसको इधर यूज करते हैं. Half times m है 1500. Higher speed है 20 square minus half into m times smaller speed 10 square. ये आ गया लॉस इन काइनेटिक एनर्जी इज इक्वल्स टू वर्क डन बाय रेजिस्टिंग फोर्स. वर्क डन होता है फोर्स टाइम्स डिस्टेंस. ठीक है, तो रेजिस्टिंग फोर्स की फोर्स है 900 न्यूटन और डिस्टेंस सेम है पहले वाला. सेम हिल, यस इट्स द सेम हिल. तो उसका भी अपवर्ड डिस्टेंस 800 meters है. So work done by the resisting force will be 900 into 800 from this formula. So work done by resisting force is 900 जो उसकी force है resisting force times distance जो है वो है 800 meters के plus gain in energy. So same hill है तो gain in energy same ही रहेगी. So gain in potential energy है ये. तो सिंस द सेम इट्स द हिल इज द सेम तो वही पोटेंशियल एनर्जी होगी क्योंकि बॉटम पे हाइट अभी भी 0 है और टॉप पे हाइट जो हमने साइन 2 800 साइन 2 निकाला था वही है. सो वो जो हमारे पार्ट 1 का आंसर आया था गेन इन पोटेंशियल एनर्जी वही हम इधर भी यूज करेंगे. which was 418,7939.04. अब इसको आप जब सॉल्व करोगे पहले इसको सॉल्व करोगे देन यू सेंड इट टू द अदर साइड and then you'll get x. This should give, in the end, you'll get x is equals to 262657,939.06 और ये वर्क डन है तो इसका फिर जूल्स ही है यूनिट. Rounded off to 3 significant figures because the answer is not exact. So 266 and then 1, 2, 3, 4 zeros. Okay, that is the answer. Okay. So chalo, that's all from mechanics. I need a 5-minute break and then I'm sending you a new link for the paper that you were supposed to do. Skip first 4 questions करने. So you can join if you've done that paper. ठीक है, I need 5 minutes. उसके बाद मैं link भेजती हूँ. Okay, see you.